Welcome to another scenario module on the forecast builder and the probability of weather type. This module is going to cover a few different winter forecast scenarios and try to give you some experience with the probability of weather type and the forecast builder in winter. I'm the Science Operations Officer at La Crosse, Wisconsin, Dan Baumgart, and we'll be taking you through this training. We're going to touch a little bit on ice accumulation and using the freezing rain accumulation model, or FRAM. Now that that has been incorporated in the probability of weather type, the wet bulb temperature has some influence on ice accretion, so we have to look at that. The use of road surface temperatures in the probability of weather type and how you use those. Also banded snow accumulation with temperatures in the 30s. And finally, a cold rain process where you have an isothermal layer that is just above freezing. So we'll talk about each of those. Let's start with the ice accumulation. Let's do a brief review on the freezing rain accumulation model. Sanders and Bargenbroek found that ice accumulation was observed at temperatures greater than 32 Fahrenheit. So above freezing, we were seeing observations with ice accumulation in that work. Also, it's important to note that ice accumulation is rarely observed, though, when the wet bulb temperature is above freezing mark. So in the study of the 405 hours of accumulating ice with temperatures at 32 degrees or above, only 15 of those 405 hours had a wet bulb temperature equal to or greater than freezing. So the important takeaway here is if your temperature is greater than 32 Fahrenheit and your wet bulb is as well, the likelihood of icing is very low. But if your temperature is above freezing and your wet bulb temperature is below 32, there's a pretty good chance you're going to see some icing. So we built that into the probability of weather type. So these three scenarios will occur now when your grid configuration matches one of these bullets. So when the temperature is greater than 32, but your wet bulb temperature is also 32 or above, you're going to see rain. When temperatures are still above 32 degrees Fahrenheit and your wet bulb then drops below 32, you're going to get a rain and freezing rain mix out of those configurations. When both your temperature and your wet bulb temperature are 32 degrees or below, you're going to see an all freezing rain forecast. So let's just take you through a scenario here. Here's a temperature grid of 33 degrees everywhere across the forecast domain, and the dew point is 32. So in this scenario, we would fit into the first category on that last slide. We have 1/10 of an inch of QPF for this scenario, and notice the snow and ice accumulation are both at 0. So we're just going to go through the forecast builder quick and go to the top-down grids to give you an idea about what this situation looks like. Again, the temperature is 32 everywhere. The dew point temperature at the surface is 32. So the wet bulb is somewhere above 32 degrees Fahrenheit. Here is your maximum wet bulb temperature aloft. So you have a warm layer aloft in this situation. So you would expect hydrometeors, ice hydrometeors coming into the warm layer to completely melt into a liquid drop. So now we're going to go into the forecast builder and just move on to the probability of type grids and take a quick look at those. Without rerunning them, you notice here the probability of rain for this scenario. Again, temperatures 33 degrees, dew point 32 is an all rain forecast. So that is our first scenario that we talked about, our first bullet on the slide. So now let's move into that second scenario situation. Again, we're going to keep our temperatures at 33, but we're going to take a different dew point grid and just copy it into the afternoon here. And here now you can see you run from 30 degrees and warm up to about 33 for a dew point in the far south. What we'll use is we'll use the query tool to simply mark out the area that's less than or equal to 31 Fahrenheit in the temperature grid here. I'm sorry, in the dew point grid. We're just going to mark out where the dew point is 31 degrees or less. And again, remember that the FRAM uses the wet bulb temperature, so we're starting to bring our wet bulb down as we cool our dew points off. So here's where the dew point temperature is 31 or less, and we'll keep that marked for the scenario training here. And we're going to rerun the forecast builder and see how that changes our outcome. Again, remember that the temperature at the surface is still 33 Fahrenheit. So all we're changing in this scenario here, where we go to precip types and accumulation grids, all we've changed is the dew point to this point. We're going to keep the settings the same in that step to create our probabilities and our accumulations. And now you notice that on the left-hand side, there's a pot freezing rain grid, or a probability of freezing rain now. And that probability of freezing rain is over the northern portion of the area. And because the temperature still is at 33, we have the probability of rain everywhere in the forecast area. And so the probability of rain, which I clicked on first, was 100 everywhere. And now, because we've got a freezing rain and rain mix in the north, we've generated an ice accumulation. So what's important to remember is that when you have this rain and freezing rain combination, you're going to take your QPF and split it both ways. Half of it will go towards the rain, half of it will go towards the freezing rain. So there's a somewhat reduced ice accumulation when your temperatures remain at 33 degrees. Okay, so now we're going to just do one more edit here. We are just going to run through the final scenario, which is to just simply drop our temperature down to 32 degrees. And now we've got both our wet bulb and our temperature at 32 degrees or less. And remember, this is our final scenario where we have an all freezing rain forecast. So notice everywhere in the domain that the temperature is 32, that the dew point is 32 or less. So our wet bulb now satisfies the criteria so that the FRAM can accumulate ice everywhere in that scenario. So we're going to move through the top-down step with no alterations. And we'll move into the create precipitation types and accumulations. We'll keep the default set. And notice we no longer have a pot rain forecast grid in the afternoon. And we've converted all that pot rain into pot freezing rain. So we have a 100 grid everywhere, and our accumulation of ice from the QPF of about 1/10 of an inch comes out to about 5 to 6/100 of an inch based on the wind speed and wet bulb temperature in this scenario. So our next scenario we're going to move through is the use of road surface temperatures in the probability of weather type, and more specifically the road temp grid. So in the probability of weather type, the road temp grid is used to counter the atmospheric conditions. So a couple examples here. When your temperature and wet bulb are 32 degrees or less, basically that the air is cold, but your roads are warmer than freezing, the road temp grid helps you account for that scenario. And then just the opposite, when your temperature and wet bulb are 32 degrees or warmer, or in other words, your air is warm, but your roads are cold, and you might get some freezing rain precipitation because your road temperatures are cold. The outcome for both of these scenarios is a rain and freezing rain mix, and a 50-50 split on your QPF. So it will equally be split. 50% of the QPF will go towards rain, and 50% of the QPF will go into freezing rain, which will make the lighter ice, a lighter icing amount for both of these scenarios. So let's just take you through a scenario here. The temperatures are all 32 degrees. The dew points are less than 32 or 32. It's basically the scenario we just left off with in the FRAM example. So we're just going to again look at the afternoon period. And the road temp grid is found under the top-down grids. And so the forecast builder will take us to that view for the browser group. And you notice that there is no road temperature grid at this time, nor do we have an option to initialize with anything. This is a hand-drawn, edited grid that you will need to add in the probability of weather type. So in this scenario, notice that before we hand edit any temperatures or road temperatures, notice that our probability of freezing rain is still 100% like our last scenario, and our accumulation of ice is 5 to 6/100ths of an inch. So let's restart the forecast builder, seeing that we have a freezing rain scenario on our hands and temperatures are 32 degrees. We're going to go into the forecast builder and show how to use that road temp grid. We're going to use it on the afternoon again, and we're going to go to the top down grids. And what we're going to do is we're going to work this from a freezing rain scenario into a freezing rain and rain mix based on the road temperatures that we see. Now, IRIS is a really nice source of road temperatures. You can plot the DOT information from the road sensors and get a feel for what your road temperatures are actually doing out across your forecast area. So what we're going to do here is just make a grid. And really the only important thing to do here is if your temperatures are below freezing and your roads are warm, just make a road temperature grid with some values that are some value that's warmer than freezing. It doesn't matter what it is. So we can populate this with anything, 35, 40 degrees, 45 degrees, it just doesn't matter as long as it's above freezing. So what we're going to do is we see an area where the temperatures on the roads look like they could be above freezing across our southern forecast area. So in this scenario, what you could do is you could take your road temperature grid and populate it from the temperature, and then just draw an edit area to increase the temperatures within that area to something above freezing if you wanted to do it that way. It's up to you how you want to do that, as long as it's above freezing. But in this scenario, we're going to just show what would happen here with a scenario where you allow your temperatures to fall a little bit during the afternoon hours, but they still remain above freezing across the southern portion of the forecast area. And we'll just interpolate that, clear our edit area, and then you can see our temperatures for the roads across the southern portion of the forecast area, mainly Wisconsin and northeast Iowa, are still remaining above freezing in this area. So this is a scenario where the wet bulb temperature and the temperature both suggest we should have icing, but you've gotten road information that suggests the roads are still warm. And so we're trying to account for that. And so we're going to go to the precipitation type creation, and remember, previous to rerunning these, which we'll see here, we just had a freezing rain grid there in the afternoon, the pot freezing rain. But let's remake it and notice now that you have a pot rain and a pot freezing rain grid. And that pot rain grid is 100% over the southern portion of that edit area that you drew, or the southern portion of the forecast area. And then freezing rain is also there. So our mix is in the south, and that's where we'll see our ice accumulations drop off. And that's because we're doing a 50-50 split on the QPF. So you notice 3/100ths of an inch over southwest Wisconsin and northeast Iowa, and 6/100ths of an inch over the farther northern areas. And the line ice accumulation is even less than that. And then just to give you a feel for what the weather grids look like during that scenario, you see down in the southern portion of the forecast area a rain and freezing rain mix, where further northwest, freezing rain is the only outcome there. So let's go through the banded snow accumulation with temperatures in the 30s. And this is more of an example of how to handle a forecast the correct way, rather than change the probability of weather type and forecast builder user interface temperature settings. So recall that in the step where you create precipitation types and accumulation grids, that the forecast builder allows you to use 34 or change these values for the threshold for all snow of 34 and the threshold for all liquid at 37. Now, there are very rare occasions where this would actually be changed by the forecaster. One scenario may be where your temperature is 36 and your wet bulb temperature is 28 or 27 and quite low, and so you are actually seeing snow falling at temperatures of 36 because your wet bulb is so low. That might be one scenario where you change this. It is important that when you do change these values that you collaborate that outward to your other neighboring forecast offices so everyone can keep the same precipitation type and snow accumulation and possibly ice accumulation as well. One of the scenarios that you might be tempted to change those numbers for is a snow band. You might be frustrated that you expect a snow band to form and that you just can't get accumulation of snow in your temperature grids that are at 35 or 36. And so your temptation might be to lift the all snow threshold to 36, even though your wet bulb temperatures might be 34 degrees or 33 degrees Fahrenheit. So what's better to do is actually build the snow band environment for the snow band into your temperature grids to reflect the heavier snow and the diabatic cooling that'll likely occur in the surface temperature. As that heavy snow comes down, temperatures are likely to cool down to 32 or 33 degrees Fahrenheit. One of the nice tools that is recommended to look at are the high resolution models in the wintertime. So some of the convective allowing models and the higher resolution core models. You can see that this case scenario here is the high res window ARW core. And in this scenario, it's May. Notice it's May 2nd here. And the model is developing a snow band across southeast Minnesota, far north central Iowa, southeast Minnesota, and into northwest Wisconsin. Notice the temperatures on each side of that snow band in the 37 degree range in the morning hours and up into the 40s. So this band is a snow band in the model. You can see the reflectivity in the lower right and the precipitation type and intensity here across southeast Minnesota. And what's happening there is that just diabatic cooling in the model is giving you some clue that you're going to drop your temperatures down within that snow band. So typically you'll see this occur at longer time scale forecasts, longer forecast lengths as well. And so it's something to really try to hone in on and use as guidance in your forecast grid. So let's just do that. Let's draw that temperature grid in. And let's draw in and add a snow band over southeast Minnesota. Notice here the dew points are all below freezing, so what we're going to do is just lower the temperatures. Our QPF is around 1/10 of an inch. This is the scenario we've been using for the first two examples for the FRAM and the road temperatures. So what we're going to do is just do a quick check on the max T aloft. The one change we've made is we've cooled this all off now, so it's an all snow or all rain forecast with temperatures aloft being cold and only boundary layer warmth changing it from a rain or snow forecast. So just reviewing the probability of weather types here quickly, the snow is off to the northwest where we have temperatures that are quite cool, and the rain is everywhere to the south, and in the middle, that 34 to 37 band is where we see the rain and snow mix over southeast Minnesota into north central Wisconsin. So we're going to start up the forecast builder. We're going to run it during the afternoon. We'll just pick today, and we're going to start with the foundation and base grids. And we're going to start by editing our temperature down into that below 34 regime so that we can start accumulating snow. We're not going to initialize any grids right now. But what we'll do is hand edit the temperature field to reflect colder temperatures within a snow band. Okay, so now we've edited those temperatures just using the pencil tool to drop them in the snow band, drop them below 34 degrees, where we think that band's going to present itself, similar to the example we saw for May 2nd, 2013 in that high-resolution WRF window forecast. Let's just save those temperatures there. And then just to be consistent, let's increase our QPF over that area as well. Obviously, in a real-time scenario, you might have more data sets for QPF that are available, and you might consider just initializing with the cons short data that would have been in that previous step where you could click on QPF to see what it looked like. Here we're just going to value it up and just do a hand edit on it for this scenario as an example. There we go. So I've bounced that max up to about 1/4 inch of liquid in that snow band area, and I'm just going to smooth it out a little bit, hit it with a couple smoother runs there. And so my QPF has been edited for that snow band, and we've cooled the temperatures in that due to diabatic cooling with the snow rate. Just as a quick look, our snow ratios are about 12:1 in this scenario. So we're going to continue on. This again was the foundational step of the forecast builder. Now we're going to go to the top down grids, and we're not going to do anything here. No reason to change those grids. Everything's below 0 aloft. Finally, to come into our step 4 of the forecast builder, where we're going to create the precipitation types. Again, remember there's a rain-snow mix. And we're going to keep those settings at 34 and 37 on the GUI window. Again, rain-snow mix was currently over southeast Minnesota and north central Wisconsin. We're going to remake those grids and our accumulations. And so our rain forecast now you can see is 32, where the 34 degree temperature line is now across southeast Minnesota. We've converted that over to all snow in southeast Minnesota. You can see that there's no rain probability there. And likewise, our snow amount grid has created our snow band in that area. So that just provides a nice example of how to build in that snow band and not worry so much about the temperature GUI and changing your temperatures. You know, the science, build in the science and the probability of weather type grids or into your grids, and the science within the probability of weather type will give you the outcome that the science will drive. Okay, and finally one more, just a cold brain process, just to give you some information about what the probability of weather type has built into the code. This is an isothermal above freezing layer, so you see that scenario right here in the buff kit sounding. You see the freezing level about 1.5 kilometers, and you see the isothermal above 0 Celsius line down to the surface. So in these scenarios, the probability of weather type has 2 assessment points that you can edit. One is the max temperature aloft, or max wet bulb temperature aloft, and also the surface temperature. So the PoWT has these 2 points to assess that layer and try to determine that environment. So what it looks for is wet bulb temperatures of greater to or equal to 1 Celsius and surface temperatures above 32 Fahrenheit to diagnose a deep above freezing layer that's in existence in your environment. In this case scenario, you will get a rain forecast from it if these 2 situations are diagnosed. If your surface temperature does fall below 32 Fahrenheit, you could actually get a freezing rain scenario out of it. So just be aware of that. So coming back to that step 4 of the forecast builder where we create the precipitation types and accumulation grids, these settings will be overridden for this scenario when the PoWT sees it. So you can change these settings in this scenario, but it won't make a difference. You will get a rain forecast from this example. So just something to be aware of with these deeper isothermal above freezing layers. So that concludes our winter forecast scenario training for the Forecast Builder. And thanks for your attention during this training.